Hi, I'm Jay Marr. I'm here with Herman from PRP, and we're assembling a new RB30 based engine for Javier's R32.
Well, it's not a JZ. There's a few little tricks, but it's just another engine.
There are quite a few tricks, and coming from the JZ world, it's really worth applauding just how far the Aussies have come with the RB platform, because pound for pound, it's hard to beat a JZ in its near stock or lightly modified form. And what these guys have done over time to create the foundation to make as much power as you can with an RB-based engine nowadays is really impressive.
Most of it's in the prep work. Well, it's all in the prep work, but yeah, I mean, years of evolution in the RB platform and what to do and what not to do. I still see internet comments about people saying, oh, the RBs have got oiling issues, but all that stuff's been sorted out. And once the prep work's done, you know, there's a few things that we do with oil galleries and bungs and blocks and bits and pieces, but once that's done, it's just another engine.
Yeah, just another engine. So we've got a 90mm stroke crank. We've got a set of, how do you say it?
IRP, or Italian Rods and Pistons, 86.25mm pistons.
Okay.
We've got some I-beam rods, and we've got our integrated main cap brace here. We've got a RB30, which is a 67S variant RB. It's not the RD, which is very similar, same deck height and all the rest of it, but it's got a higher deck than the RB25 or 26, so it allows for a bigger stroke crank and a longer rod.
Yeah, it's pretty neat. In terms of space, you know, your deck height is how much stroke and rod length and compression height, how that all fits inside the engine. So this is right around 9 inches of deck, where the JZ is 8.6 inches of deck. So you have essentially 400 thousandths of an inch to fit components, which really loans itself to making, you know, if you wanted a longer rod or a longer stroke or a more substantial compression height where you can fit a bigger pin, deck height is definitely your friend. So over the fairly short RB26, which is 7.9 inches.
So you're talking numbers I don't understand.
Oh, inches and millimeters, sorry.
We get stuck. But you're right, we don't have a lot of deck height, and with our new block, we've been able to give it 2mm extra deck height, which has made the world of difference when it comes to gudgeon pin location and where the piston ends up, the length of the conrod, which is worlds apart from where we are used to plotting out RB26s and 28s. But yeah, you're right, that extra deck height and being able to increase it is monumentally better.
There are quite a bit of modifications done to the block. Can you go over some of the operations that are going to allow this assembly to work together and live well?
Yeah, so we're used to using a much shorter crank, well, less stroke in an RB30. So when you go to a 3.2, it goes from 86mm to 90mm, and that extra throw causes you some problems with the conrod hitting things inside the cavity, the engine cavity. So we have to go and machine some reliefs for the conrod in the base of the bore, and then also the main oil gallery. The conrod hits the main oil gallery, and it's all good and well to assemble an engine and you go and put a piston in or 2 pistons in, however you do it, you go and turn it around a third of a turn and all of a sudden it stops and you've got this problem. So machining the block and clearancing everything before you go for a final build, obviously it's essential, but if you already know what you're doing before you're doing it, like we've done with this one, it makes for an easier build.
Yeah, so this engine was put in a model, and a CNC machine went and gave just enough clearance just where it needed it, because you don't want to take off too much material, especially when you're backing up against oil galleys, and you want to take the least amount of material out of the bottom of the skirts, because that's how you're retaining the piston. So just done on a CNC machine, it's a fairly precise operation that allows everything to fit together well. Doing it with a hand grinder, much more tedious and a lot more margin for error. The other thing they did was they cut a groove in the oil main, so you have a bearing that's going to be oiling through multiple oil inlets, so there's a larger reservoir available, keeping oil available for the crankshaft to keep the bearings alive, which is a pretty nice touch over just having a single oil inlet on the bearing.
Even pressure along the back of the bearing coming in through multiple holes, it all helps stabilize oil pressure. and surfacing across the bearing. But to cut that annular groove is a little bit tricky, doing it by hand. I have seen some people with, you know, some medieval contraptions to cut annular grooves, and it works, but having a CNC with a ball nose cutter come in and hit it a couple of times, it's a lot quicker.
Yeah, and we've also, there's an increase to the main hardware.
Yep, so that goes from an M10 stud, we go out to a 1/2 inch. A lot of people also go an M12 bolt. We just go 1/2 inch because the deck is also 1/2 inch from an M11. We machine it out to a 1/2 inch stud because you can't go M11 to M12, there's not enough thread bite.
Okay.
So you find yourself tensioning the bolt up and it'll go pop.
Yep.
So going to a 1/2 inch, it's just the next easiest upgrade, and it's a cheap and available stud, ARP or whatever brand you want to use. So you do the main studs and the head bolts, 1/2 inch UNC. Fixes that problem.
Okay, and there's going to be some order of operations as far as fitting the girdle to the engine block, and we'll go through that as we get the process rolling. But for now, we can get the bearings in the block, get the crank in the block, and start mocking the rest of it up.
Next thing we want to do is put the oil pump on. Has to go on first because we torque down the bed plate or the brace over the oil pump, and it's really hard to work with after that. So usually I'd go and check the oil pump alignment, but now that I've already done it, I realized my dowels had to come out because I wasn't having the movement to get my pump in the right location. Why is the pump in the right location or not in the right location? Well, if you main bore, tunnel hone your main tunnel, that position changes off the OEM. So the original alignment dowels can no longer be the right spot for your oil pump. So usually pull those out, and then we can go ahead and put the oil pump on. This time I'm going to use a gasket because I know it's right already and we don't have to pull it apart again. Okay, so I just leave these a little bit loose. You only need a couple, but right now we're just going to stick in more than a few. I'll leave these ones out because there's a crank trigger that bolts to that one, so I'm going to use all the other ones. Make sure the oil pump's still moving, and I put in my oil pump alignment tool. I have to jiggle the pump to get it in. Once that seat's in, we're happy, we know that's all aligned. Now I know there's no tension or anything on the main cap brace, but we're talking tenths. It'll be fine. We can leave that oil pump collar on, put some tension on the bolts. We can give them a final tension up later. But as long as that oil pump collar still moves, we're in a good spot. Beautiful. We can leave that in for now anyway. Okay, now we're ready for the main cap brace. Now there's a couple of main studs here in a four-wheel drive application. There's a drive shaft that goes in the way, in the sump. So what we do then is cut about 1/4 inch of the stud off to make it easier to assemble the sump.
What's that in millimeters?
It's about 7 or 8 millimeters.
Okay.
As a guess.
Well, we lost you on deck height
Yeah.
with this metric system stuff.
9 inches. I'm like, I know what 6 inches is, but not 9, sorry. Main cap walk is a pretty serious thing in an RB, it happens a lot. So how do you stop the main caps walking around? It's already got a standard girdle that connects all of the main caps together, which is a pretty brilliant idea from Nissan. So why cut them individually and make a hard steel cap that has its advantages and disadvantages, and this is not about that at the moment, but I thought how to tie it into the pan rail without doweling the crap out of all the caps. So I thought, why not make the original version but tie it into the pan rails without having floating parts. So we made the first steel integrated main cap brace. That has it had its own challenges because it kept not wanting to settle, and every time you tension the main tunnel and cut the main bore and then you back it all off and measure it again, it was all over the place and it would warp and change and it didn't want to settle. So we found that we had to settle the block with, and we tried heat treating, we tried everything. We tried then to settle the block by leaving it parked for 6 months with the brace main cap tensioned up, and then you'd start to get some consistency in the measuring of the, of the main bore. We thought that wasn't good enough, so I went and saw a metallurgist friend of mine and we came up with a new composition for a ductile cast iron, which ended up forming this brace. After we machined the first core plug and got that right, we tried a few different grades of ductile iron. We found one that was really stable, it machined really nicely, had a nice chip rate, it was easy to treat, blacken, heat treat, and you'd pull it off and put it on back on 20 times and it was all very consistent. So we feel we found the right solution for this engine.
That's cool. It's pretty interesting. There are many engines that had factory girdles of sorts. You could pop the oil pan off your Evo and some of the main caps were tied together kind of as one part. And that all kind of gave way to the bed plate, because the bed plate puts the main caps and the pan rail in one piece. So this is a good hybrid of a bed plate. And while we don't need it in the JZ world, it sure seems like it plays a role in your world.
Should we make it for the JZ anyway, though? It's JZ. I'm pretty sure it's JZ.
JZ.
Is it JZ?
Yeah, it's A, B, C, D, E, F, G, something, 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 Z.
Z. Still not working.
Yeah, Z.
You'll notice on this block, these counter sinks on this pan rail have been slightly oversized and machined in a different spot because the pan rail bolts were not drilled evenly on a Nissan block, and that happens all the time. So you kind of have to get the best of what you can with what you have. Main cap registers are skewed, you have things that don't line up, you have to machine the oil pump down or the rear main plate, and you just have to sort of massage things to make it work. But there's always a way to get things to settle and sit right. But if Nissan had the technology that they have now with the VR38 back then, which is 30 years ago, it'd be a very different looking block, I'd imagine. It wasn't what we call precise these days. So you just got to work with it. Still the best sounding engine ever. Checking a thrust, we want to have 4 or 5 thou end float on the crankshaft. So just between the main cap brace and the flyweight, we push the crank all the way forward, get a measurement, then all the way the other way. It's actually not too bad. We've got about 3 thou. It's pretty right, but we still settle the mains, and I'll still show you how to settle the thrust. So I'll still show you how to do it because this one's probably already been settled, but it's fairly barbaric.
A main cap, unless it's doweled or bed plated, there's no way to align the upper and lower thrust.
That's right.
So you're going to mechanically align them with sophisticated devices.
Absolutely.
We're missing the other sophisticated device.
Is this calibrated?
It hasn't been calibrated by an alcoholic,
Okay,
but it's pretty good.
it's pretty good.
Yeah, give it a whack.
And then get into the other side. And you can do it anywhere on the crank. I just prefer to do it on the back.
And what you're doing there is you're shoving the thrust face of the crankshaft all the way back and all the way forward, and you're aligning those bearings because the crank thrust is true. It's turned on a lathe. The block is a half and the girdle is a half, or main cap is a half, and when you hit the crank, it basically lines those halves up, so your upper and lower thrust bearing will then have an equal amount of clearance. A lot of people that have thrust problems that aren't related to the transmission forcing on the crankshaft, or just through this process here where those two upper and lower halves are not in alignment with each other.
And what happens if you don't align them is you start to create heat when the engine first starts up, and you'll create friction and you'll push the oil out of the surface, and all of a sudden you start munching bearings, thrust bearings, and then that thrust goes through everything else and ruins your fresh new engine.
Yeah, a lot of money. Crank walk is the term we used for a bit. Is that what you guys called it?
Crank walk. Yeah,
crank walk.
We can run with that.
See, we agree with that.
Yeah,
crank walk.
Finally, on something. All right.
5. I think it's good.
We're good.
Yep.
So now we can finish tensioning the main cap brace, and we might check it again when we're done.
I like that. Another thing that you can do if you're doing this type of work at home is measure the end play with the block and the crank without the cap, and then measure the end play when you have the two together and just make sure they're the same. That helps tell you that you don't have a difference between the level, the upper and lower thrust bearing. So the thrust is good. Crank feels nice. Want to get that a spin?
Yeah, it's good.
All right.
No
so
hard spots.
We have another trick. Let's flip the engine over. And Herman gets to show us another RB specific thing.
Trickery. The backing washer. There's several different types of these washers, but fundamentally they all work the same way. And we just want to make sure, now that we've put our gasket behind our oil pump, we want to make sure that this goes on and bases out on the collar neck of the crank.
Okay.
And stops there and doesn't hit the oil pump, which in this case, we're good. There's a gap there.
Okay, so as long as you have clearance between the washer, if you don't have clearance between the washer, take the oil pump back off.
Remove the gasket.
Remove the gasket.
Good.
Silicone. Mm-hmm. Okay. So you probably want to check this before you put the girdle on. That way you don't have to take the girdle back off.
Absolutely.
Okay. Clearance between the washer and the snout of the crank.
People ask why that changes, and I'll just address it now. Nissan cut those thrusts, I think, on a manual machine, and the position for that thrust changes. There's also aftermarket cranks. There's variables as to why a crank snout ends up where it is, and also aftermarket collars. People tidy up the nose of it when they do a nice machining job, not thinking that it's going to cause you a problem later.
Right.
A heap of variables that can cause you an issue there. But as long as you're not galling up the back of that washer and cutting up the oil pump, you're good.
Okay. Cool. Tell me something I want to know about an RB. Tell me something that makes it exciting. When you guys started messing with these engines, what was the point where you're like, we're not going to really go down the JZ rabbit hole. We like this about the RB. What was the this? Was it the chassis it was in?
Have you driven a GTR?
No.
We need to change that.
Okay.
It's a beautiful feeling car. And whether it's a 32, when I first got in one of them in Japan, I was buying cars and importing them in Australia. You just get in the car and the seat just feels nice. And when you drive it, it just feels like a solid car, and you get used to the engine platform and the noise. And that's just where it started. Now, we were importing Supras at the time as well. And sure, it's a nice engine platform and the car's awesome and we were getting lots of money for it. But just to me and a lot of other people, the GTR just feels nice.
Yeah. I would like to drive a 600 or 700 horsepower R32 because that's the one I would own. I'd want to scratch that itch and say like, okay, I like this.
And look, a standard car to drive with its 208 kilowatts, it's boring. It's pretty boring. I don't enjoy it.
Well, I don't know that the last time I drove a dead stock USDM twin turbo super, I really enjoyed it. I was like, if I could have a stock one and a modified one, I'd have two.
Yep.
You know, just because then you could have the authentic personality of the vehicle as the manufacturer put it together, and then as we made it more powerful.
I've got an N1 at home, and it was just boring. So I did a few things. I put an M-Tron in it. I did, you know, some trigger kits and coil kits and little bits and pieces, gave it a little bit more boost, and it's just a nice car to drive, and I'd call that standard.
Yeah.
Yeah.
All right, well, let's assemble some pistons and rods, and we'll load those in, and we'll be about ready to have a completed short.
Sounds good.
So these were knock-ins.
These are knock-ins from factory.
Okay.
They're not usually peened. So we removed them. I can't remember the thread size, but we had to make up this particular bung to get the right
so
size.
That's not quarter pipe.
It's not quarter, it's an overgrown quarter.
Okay.
So it's not a standard fitting. So we made them purple so people know that they're ours. But yeah,
Do you sell a tap?
we sell a tap, and it's off the shelf tap, but the bung is a custom size bung because it's a bigger bung than your standard lead-in.
You got to take them out because you have to get all the particulate that happened through machining. So you take all your plugs out, and instead of putting knock-in plugs back in, screw in plugs.
Screw in plugs. Now, really important with these, there's a main oil gallery that feeds the main. All the mains are fed off that oil galley.
Yes.
Now, if you screw that bung in too far, front or the back, you cut off the supply to the main oil gallery on 1 and 7.
Yep.
So,
Smoke the crank right out of it. Okay.
one other thing while we're here, I'm going to show you the oil pressure bypass valve. There's an oil gallery bypass, which is just a ball on a spring in a valve that is a bit hard to get out, but you get it out with a screwdriver. And that lets the oil pressure bypass the filter when it needs to. Now, because this is what we would call a race engine, making over 1,000 horsepower, I like to cap it at 800. A street car, you might want to leave it in and not filter all of your oil and have a bypass for safety. But if a race engine, you're going to arguably drop the oil very often. You're going to filter all of your oil because you can't afford to have any metal shavings going through your engine at any time. Or
The bypass is so the oil filter doesn't blow up when it's cold?
yes, and also to not have to filter all of the oil, because in a street car you shouldn't have to filter all of the oil.
Right. Well, once the engine's established and not making metal, there isn't much particulate ever to be caught.
True. But in this particular application, you want to filter all of your oil all of the time. So
Yeah.
we bung that.
Right on. Plug.
Plug.
Got it. Got it. It's got to be very complicated being Australian because you bounce between the metric system and the old
It's
regular numbers we use here in America.
It's all metric. It's always metric unless you're building an engine. And there's some people that talk in horsepower and some people that talk in kilowatts.
Oh, this thing's going to make heaps of kilowatts with heaps of boost?
Heaps of killer wasps with heaps of boost, mate.
Got it. Got it.
Now there's a bung at the back, but I can't quite get to it yet.
I'll get that one when I get it off the stand.
We also have some Welsh plugs. What do you call them here? Freeze plugs?
Freeze plugs.
To stop things freezing?
Well, when the person doesn't have coolant in the engine and it's freezing, you hope that a plug pops out before the block cracks.
See, in Australia, nothing freezes. It's not cold enough.
Yeah, in America, Some places it gets pretty gross.
Pretty cold.
Pretty cold. It's worth noting, if you're not going to use a screw-in freeze plug, you want to make sure the freeze plug fits extremely well, because it can vibrate out or pop out under normal operation, or if you lift the head, it will blow out and you will have a lot of coolant under the tires in a very short amount of time. It's one of those things that we are far along enough in this process that using coolant pressure and proper bypass valves for the cooling system, if you do have a cooling system, is a smart way to not crash your car.
Pressure sensor.
Pressure sensor and pop off.
And a pop off. Because coolant is very slippery, isn't it?
Very slippery. Under the tires.
Slippery sucker.
With heaps of boost.
With heaps of boost.
Yeah. What do you call it in Australia when you recognize that you've totally lost control of the vehicle?
Yeah.
Okay, that's it. This is the main galley, and it comes up and it feeds the head in 2 locations.
Well, in a hydraulic head, you feed in 2 locations.
Okay.
So an RB30 single cam head or an RB25 non-Neo head, you would feed through both locations with a restrictor. Now they come factory with restrictors, but we downsize them to stop the amount of oil pooling in the cylinder head. But when we go for an RB26 solid type setup, we block one of them, usually the back one, and we still restrict the front one according to how hard and fast the engine revs. So we have several restrictors available, 1.5, 1.3, 1.1, 0.9. The harder and faster the engine revs, so closer to the RB26, the smaller the hole, and the higher, and the slower it revs, you can afford to have a bigger restrictor in the front, unless you're sticking to hydraulic and then you want 2 1.3s, for example.
The camshaft core is smaller on the RB, so you have a faster lobe speed.
Yep.
Do the buckets live well?
They live. They could live better.
Okay.
But DLC coating definitely helps. But you don't want to starve the top end of oil as much as you don't want to have a pooling of oil. So
yeah, it's a balance.
It's a balance, and it's been worked out over years. But years ago, the go-to was a 2.2 millimeter restrictor, and it still just put way too much oil in the top, and you're frying bearings down the bottom. So anywhere between a 1.1 and a 1.3 is fairly well happy go-to, and an RB30 1.3 and an RB26 or 28 1.1, 0.9 if you really have an issue with circuit racing and you want to keep the oil out of the head. But then again, you should be going dry sump at some point.
Yeah, dry sump, dry sump, dry sump.
The timing gear we can put on for a vid.
Because this engine natively had a cam angle sensor on the intake camshaft.
Well, technically, the RB30 had a distributor and leads.
Oh, because this engine was for a grocery getter.
That's right. But the twin cam head then had a CAS, a crank angle sensor that drives off the exhaust cam. So because this block was never designed to have a twin cam head, the idler and tensioners don't work. So we drill a tensioner, a guide tensioner hole here, and the idler goes down here instead of having both guide and tensioner next to each other on an RB26. That hole doesn't get used in the RB30. So it basically gets relocated. The tensioner goes here and the idler goes down here, and it all works.
Do you mind if I make a job? In America, we just used the 2JZ and we didn't have to rely on repurposing a grocery getter engine with the correct cylinder head.
Yeah, that's fair enough. Yeah. So there's a tensioner, a drilling tool that we offer for the RB30, and you just flip it around. One's a drill hole and the other one's a tap hole, so you can keep it straight and not have a CNC or a bridge port. That's all done. We need a water pump. We need some timing gears. There's a Welsh plug in the front as well. That has to go on before the water pump. And then we can put a Woodruff key in. This one's got a single keyway that we modified, but you can use the 2 half moon type keyways. Mm-hmm. And then that is all happy, and we can put the trigger gear on the engine, and we're pretty well set up there.
Right on. I know that you didn't build the engine that Javier was using in the car at first, but there are a fair share of upgrades between that engine and this engine. Can you go over what makes this a better engine to move forward with?
Well, I mean, we still guided Javier and Andre in that first build because it was a new thing for Javi. It was cutting teeth. but they retained an 11 mil or a 12 mil stud, which isn't ideal. We've gone to a 1/2 inch here. It utilises the overlay brace, which we like to rate to 1,000 horsepower, and this has got the new integrated brace, which we didn't make at the time. Also, this block was sonic tested by us, and his first block, I don't believe, was. So we have a system of rating the cylinder wall thickness and hardness to give us a matrix on how we rate the block. And the maximum rating we ever give a RB30 is 1500 horsepower due to the deck thickness, no matter how good the bores are. An RD28's got a 12 millimeter deck, which is obviously a different kettle of fish because you've got the rigidity in the deck.
Yeah.
So this particular block got rated 1500 horsepower. So it's a better block. It's a known quantity, and now we've freshened up with the new Italian rods and pistons stuff, which is not new now, but at the time that we organised this build, it was new, and it's still awesome gear. And then we've got a 3.2 stroker crank like the other one, but it's just fresher.
Okay.
We've gone to a Pro trigger now. It's got a billet oil pump. It's had a few upgrades, but we know what the block is. It's most important.
Something can be known, it should be known. So if you're digging through cores that have questionable integrity, sonic testing is a really old technology of just understanding how much material is there. That's going to have a lot to do with how the engine lives and dies. It's just how much material is in the cylinder walls, how do the cylinder walls keep shape under stress, and how does that deck keep shape under stress, because all that boost is trying to move the components around. And the thicker you have in a deck and the thicker you have in a cylinder wall, the better the components are going to keep shape. So the girdle does a good job of tying the bottom of the engine together. Unfortunately, without sonic testing, you don't know what you're getting into in the top half of the engine, which is arguably just as or more important.
I think we touched on grout filling at some point during the build, but although it's not essential now to stop the block so much twisting, which is one of the techs that grout filling was filling a void on, still we have a weak cylinder, so we still grout fill them about to the bottom of the higher side of the Welsh plugs is usually just rule of thumb. It heats oil up a little bit more. Obviously the heat's got to go somewhere.
Yeah, because it can transfer.
Yeah, but it has got other properties which help absorb noise and vibration in the block, and it gives you a sturdier bottom end. So,
well, I appreciate the education and the opportunity to work on another well-renowned and exciting turbocharged platform that's in the same community as the JZ. So I appreciate you sharing with me, and get this thing back to Javier and get it in the car and get to the track and start making some laps.
Thank you for the opportunity. I had fun.
Yes, sir.
Thank you. Let's go. Try and keep a straight face. Cool. He's laughing.